right-handed species somewhere, there is a left-handed species somewhere. One of it we classify as matter and another as antimatter. And we also understand from the very fundamental areas of science that particles and antiparticles, matter and antimatter, something and its opponent, they always annihilate each other and we are left with energy only, right? Now, the basic question is that if at the time of creation of this universe, which is Big Bang, matter and antimatter were present in equal amounts, which they should have been, because there is no law of physics, there is no understanding of any sciences that can compel us to think that matter and antimatter should not have been in equal proportions. They should have been. All laws of probability, all laws of physics, all laws of matter, they tell us that matter and antimatter should have actually been present in equal proportions at the time of Big Bang. But if that were the case, that matter and antimatter were present in equal proportions, then it should have so happened that matter and antimatter annihilate each other, they neutralize each other, resulting in the manifestation of energy only, radiation only. But the question is, what about the material existence of this world? Material existence. All of us, you and me, especially human beings, we are a part of this material existence. So we could not have come into being unless there was a little matter over antimatter or antimatter over matter, which did not cancel out and manifested itself in the form of all the tangible existence of this universe, right? So we are here because of an inequality. Either matter exceeded antimatter or antimatter exceeded matter. All of us are here because of an inequality. Now, because we chose to classify all this energy broadly as matter or as radiation, so the fundamental quantum, one quantum of energy, one quantum of, say, light. See, whenever we choose to classify matter, we say there is some constituent particle, fundamental, at a very fundamental scale, that constitutes it. We call it atom or molecule or cell or a subatomic particle. But what about matter or radiation? There is one quantum, one packet of radiation that we call as photon. So we should understand that from the Big Bang, the most abundant non-material particles, because they are not tangible, they are photons. The second most abundant particle is neutrino. But we can also choose to speak in this way that the most abundant material particle in the universe is neutrino, right? So I have shown those two pics over here. One is the quantum of radiation and another is the most fundamental material particle and also the most abundant, that is neutrino. I also want to tell the audience, because I have a mixed audience before me, not to confuse neutrino with neutron or proton. Neutron or proton is a subatomic particle. Neutrino is something different from that. It is also a subatomic particle, but inherently it's not part of nucleus. It is generated during the course of radioactive processes. Now, if you check the human thumbnail, roughly our thumbnail, it is roughly 1 centimeter square in area, and you will be amazed to know that 65 million neutrinos pass through this thumbnail every 1 second. Then through our entire body, these many neutrinos, 100 trillion neutrinos pass through our body every second. So I should say that neutrinos are actually, they are jam-packing the universe, they are everywhere. They are produced in cosmos, they are there in cosmos. They are produced from sun, they are there in the atmosphere. They pass through us, they are all around us, right? Now the question is, why are neutrinos important? Because neutrinos are the only species since the Big Bang has happened which have retained as neutrinos. Everything else changes into something else of its own accord. For example, as chemists we know that carbon reacts with oxygen to give carbon dioxide, hydrogen reacts with oxygen to give water, or something reacts with something to give something else. But neutrinos are very weakly and very feebly interacting particles. They may interact once in a lifespan. They may interact 1 in a billion encounters and change into something else. So we are interested in neutrinos because they could be carriers of information from the remotest history of universe, from the remotest distance, from the remotest sources of the universe. They could be the carriers of information. That's why we are interested in them. In fact, not just we, the whole world, all the scientifically contending nations at the time are interested in neutrinos. And I say it with whatever authenticity I can command that this is something which is going to take over us in future. I would also like to mention one statement to compensate mine in this context, that in 2009 when I was a student at University of Kashmir, we have had one such conference in University of Kashmir, and we have had a reputed scientist from ISRO, one of the directors at ISRO by the name S.K. Pathan, Mr. Subhan Khan Pathan. He made an explicit statement about neutrinos, and I would like to quote that here. He said, "Everything in the world in a few decades from now may choose to be neutrinos only." The end product of every decay is neutron. That's why we are interested in neutrinos, and there is a kind of mad race among the scientifically contending nations today to pursue the neutrino studies. I would like to name a few experiments, rather observatories, that are running in various countries, scientifically advanced countries, because someday they may pop up in the news and you may not know what this is all about. There is one good experiment or observatory by the name IceCube. It's at Antarctica. NOAA is in the United States. Cameo Candy, it's not a candy, it is in Japan. Dayape experiment, it's going on in China. Choose and double choose, that's in France. And Dune is an upcoming experiment that United States wants to take up in 2025. Now, what is India doing about it? I should say that one of the biggest scientific endeavors of the country currently is INO, Indian Neutrino Observatory Project, and I had the good fortune of being a part of this association, this collaboration during my PhD program. I hold my PhD in this very subject. The location of this observatory is Bodh Gaya Hills in the Thini district of Tamil Nadu. So the observatory is not yet, completely functional, but it's going on. This idea was given to Government of India in 2005, but then it got approved in 2015. I should say one thing with here, I don't know how many of you will excuse me and will not excuse me for making that statement. India is primarily a land of literary people. They don't have much scientific taste. As of now, they did not have, but maybe post-independence, because post-independence, we are yet to have a Nobel laureate who comes from India. We don't have any. We have many from our neighboring countries, but India is yet to have since its independence. We are basically the land of literaries. Nonetheless, we have just geared up in the field of science also. So the essential objection that was there in erecting this observatory in the Thini district of Tamil Nadu was the concerns for biodiversity. The common people were taking it this way. They were saying that these scientists are going to bombard us with some kind of nuclear radiations. So this will have health hazards and other effects on our biodiversity and also other habitations around. They were worried about tigers and trees and their livelihood and the general human habitation. But in that direction, what has been done is that some public outreach programs have been taken out by various